This conference will now be recorded.
Okay, great. So what we have seen till now is that we said we had an image, we don't even need this. We said we had, let's say we were creating images out here, and we basically went inside the image and basically we were building our own images and pushing it, let's say, to something known as an Azure container registry. And from the Azure container registry, we were using something known as an ACI, Azure Container Instances. Is this good enough? Yes, it is definitely good enough. Azure container instances are, very good PaaS service and all that stuff. Good enough, but it's not the best solution available out there for managing your containers. Meaning, in the real-time environment when you're working, right, you won't have one container, you will have multiple containers that you're working on, hundreds of containers that you'll be working on. Because it's not just going to be you, it's going to be a lot of people in your project creating containers, want to test out their changes and all that stuff, for which Azure container instances do not offer something known as a scalability, meaning according to the load, according to, let's say, the load, according to the traffic and etc. Azure container registries or Azure container instances, sorry, will not scale up or will not come down. It doesn't do all that stuff. You need someone or you need something to manage your containers, right? You need someone or something to manage your containers. How do you manage your containers? What kind of a technology that you kind of use use the container managing and all that stuff? This is known as orchestration. What is it? Orchestration. Why am I calling it as an orchestration? Because when you go to an orchestra or something like that, right, you'll have one person who's like controlling the entire band with a stick, telling that okay fine, this is how you basically have to sing, or this is how you basically have to play the music around, when should some play, when should not some play, and all that stuff. You need someone, an orchestrator. This person who's basically controlling the entire thing is called as an orchestrator. Someone controlling the orchestrator, you need someone like an orchestrator for your containers also. And the container orchestration technology, one of the very popular available container orchestration technology, is Kubernetes. Now, what exactly happens in Kubernetes is something like this. Now, Kubernetes is an open source available software. This is by Google. You can install Kubernetes on a virtual machine, right? The first virtual machine that you install Kubernetes on is called as a master node. Now, I am not calling this as a virtual machine. I'm calling it as a node out here. Okay. It's called a master node. This is the master machine which controls all your slave nodes, or the other machines that you create out here are known as a slave node. So slave node, you will install the same piece of software called Kubernetes and connect it to the master. Connected to what? The master. All these are what? The slave nodes, or just simply called as nodes. You'll connect all these nodes to the master node out here, so that the master can know what should I manage. The master now will understand what do I manage, how do I manage it. So first terminology is called as a node, master node and slave nodes. And you will now basically drop your containers on these nodes by using a command called as kubectl, for which you need to install a command line interface for kubectl, which is a language for Kubernetes. And as and when you drop the containers on top of the node, the containers are now called as pods, not nodes but pods. Now the master is responsible for managing all your nodes and pods. Meaning, if there is an unhealthy node, it'll take off that node, shift your pods to some some else nodes out here and all that stuff. And if this is a public application, your Kubernetes is also going to implement something known as a load balancer technology out here, and expose your applications to the internet traffic over the public IP of the load balancer. This is a service, and this is called as a load balancer service out here in Kubernetes. And every container that you drop on your nodes are called as pods. These are called deployment pods and everything, and as such, or we simply call them as deployments. This is the vanilla flavor of Kubernetes available out there, meaning if you are from a cloud like AWS and all stuff like that, right? Like even AWS right now offers something known as EKS service and all that stuff, Elastic Kubernetes service and etc. But if you want to something basically use Kubernetes as an infrastructure as a service, I'm not talking about Kubernetes that is offered by Azure. I'm just talking about the bare basic Kubernetes that is available out there. This is how you basically configure, and this basically takes a lot of skill and it takes a lot of commands and all that stuff. But this is something that we're not seeing it. This is something that we're not looking at. This is the Kubernetes available out there in the open source. Like this is the Jenkins for Kubernetes as such. But what we are seeing is a platform offered service, which is called AKS, Azure Kubernetes Service. Azure Kubernetes Service, wherein the cloud provider kind of manages the master node, kind of manages all these things. All you need to tell the cloud provider is what is the configuration of the Kubernetes cluster you want. The entire thing now is called a cluster because it's not one, it is multiple virtual machines that are running out here. You are just now telling the cloud provider what is the configuration of your cluster and what kind of nodes that you want on your cluster, how many nodes that you want on your cluster, meaning very simply how many virtual machines that you want inside your cluster. Do you want a 2 node cluster, 3 node cluster, and etc.? And what should be the capacity of each and every machine that you're provisioning? What should be, let's say, the capacity of each and every machine that you're provisioning, and how should it scale out or scale in? All these things can now be taken care by a service called as an Azure Kubernetes service out here. Guys, does this help? Like, does it make sense? Any questions with this explanation of Kubernetes, what we are going to look into? I'm just giving a bare basic introduction on what Kubernetes really is and why we use it and all that stuff. Is this okay?
So this Kubernetes only responsible for container orchestration only, right?
No, it's actually more. So yeah, you go ahead. You cannot use it.
Yeah, same question. So it's only responsible for container orchestration, or it can do for more?
No, actually, it is actually a lot. Kubernetes is, yes, primary responsibility of a Kubernetes cluster is for container orchestration. But at the same time, if your containers goes bad, like if your containers are unhealthy, it will replace those containers as well. It will do a lot of things out there. It will do a lot of management out there, and it'll give you an excellent monitoring service as such. That's the reason Kubernetes is taking a huge lead in the market today. Like if you are going ahead and deploying a container on top of a web app, which is good, not an issue. But if that web app goes down, it's your responsibility and all that stuff. But in a Kubernetes environment, it is actually far more sophisticated. Like Kubernetes is a very I would say, like, it's been in the market since the last 3 or 4 years. It's something that I've been hearing. It's very sophisticated right now, and it's like, it has auto healing capacity and it does all that stuff. We'll look into that as well, like, what exactly Kubernetes does and all that stuff.
Okay.
Okay, any further questions with this, guys, before we go ahead and start creating our cluster? Okay, now before that, now normally, right, even Azure Kubernetes services or Kubernetes, when I'm talking of deploying an application or a container in a form of a pod or a service, or or a load balancer in form of a service, the accepted language for Kubernetes is YAML or JSON, any one of them. But since we're here, let's understand a little bit about YAML so that we can understand how to do a deployment in Kubernetes and all that stuff, which will help us. So let me open up, let's say, my VS Code out here, and let me just type in a very simple YAML file to understand what is the syntax of it, to understand the syntaxing of YAML. So let me close all these out and let me open up a new folder out here, and I'm using VS Code in order to write my YAML files, okay, because I have an extension called YML or YAML extension out here that is installed with me. I have a YAML basically that's offered by Microsoft and Red Hat. These are the two things that I've kind of implemented out here, or I basically installed out here. So I can say, okay, fine, I've installed YAML, which is good. Now I'll basically open up a new folder out here. Inside this particular folder, I'll say it is a new folder, and I'll name the folder as test YAML, and I'll say select folder. So I'm just opening up this folder and I'm just writing my first YAML file out here. So let's talk about what is the syntaxing, how do you write about YAML file and all that stuff. Say I'll say classes hyphen or classes dot YML. YAML or YML, anything is okay, anything is good. Here, what you can do out here is that, let's see. Now I want to make sure that I provide a list of students along with their IDs, along with their phone numbers and etc. that are attending my class. So I will basically list down a parent entity called Azure DevOps class. This is the parent, meaning the top level called as a class. I'll say semicolon and I'll come down. I'll give a tab. Spacing in YAML is very important. I'll give a tab and I'll say hyphen, meaning this is now a child under this particular parent class, and I'll say student name colon space. For example, let's say, like, I don't need quotes out here, let's say Chandra, and I can now I want to give the phone number of, let's say, Chandra, so I want to make sure to list it under the parent, right? Give a tab and under the student name I'll say phone number colon then space, say 9 something something something, then email ID I'll say xyz@gmail.com. Now, is Chandra the only student? No, I also have a lot of students like Akila and a lot of students like Sanjay and all, right? So I also want to make a list of them. Now I'll say, okay, fine, enter, do a backspace, hyphen, space, student name. And I'll say, fine, the name of the student is something like Sanjay. And I'll also say, okay, fine, phone number is something like 98 something xxx. And then I will, let's say, also give the email ID is something like test@gmail.com. Now for Chandra I also need to, sorry, for Sanjay I also need to give the address of him because that's also a field that I have. So I'll say address, and I want to fill in details like house number and etc. under the address. So I'll do a tab under the address. I'll say space house number HNO space something like 27 dash something like this 8 something like an imaginary number out here. Then the lane something like second lane, then the street something like 8th street, and the city something like second. So all I'm trying to say is that this is the parent resource. If I collapse this, everything is getting collapsed, under which you have multiple resources. For example, Chandra is this the block, and this is the student name with Sanjay, and Sanjay also has something like an address out here. So if I collapse this, right, all this address is here, and I can give multiple addresses out here. This is the primary address, this is the secondary address, and etc. I can mention this. And if I want to now give an address to Chandra, I need same address block out here and then a child under it. Meaning, how do I define a child? Tab, meaning one space out here, hyphen, space, and then all these things. Meaning, this syntax, right? It's one of the very purest available syntaxes out there. Like, it's very simple to understand, but the only thing that you have to take care about is the spaces. This is important. If I don't give a space, right, it'll start throwing errors. It'll simply start throwing errors telling that, you know what, I don't understand what you're talking about. You need something known as indentations or spaces out here. This is how you write a YAML syntax. This is how you generally go ahead and write a YAML syntax out here. Guys, is this okay? Is this syntax understanding okay? Does anyone have any questions with this one? Anything, guys? Am I good to go ahead?
Yes, yes.
Okay. So you can also basically do a formatting of it in VS Code. Say format document, and the spaces and all will be formatted properly, so that it's visually very good represent. I mean, it's visually representing very well. Fine. So this is how I'm declaring a YAML syntax. Now then, how can I use this YAML syntax for a service like Kubernetes? How do I make sure my deployments are there? So I am talking about two things out here. One, I want to deploy my pod, meaning my container. Second, I want to deploy a service called a load balancer. Two things. And these two things can be declared in the YAML syntax telling that this is what I want. And I have given the YAML files also out here. If you look into the repository and look at Kubernetes out here, and if you go into simple, I have something known as a app.yaml file. So I'll just take this out. I'll just paste it, let's say, in my local machine. Let's say the language is YAML. Paste it. I'll say save. And I'll say this is app.yaml, YML. And what am I declaring out here, if you look at, is that I'm saying the API version is something like this. And the kind is a deployment, meaning I'm telling this is a pod. And I am saying the name of the deployment is app-deployment. This is the name. Anything, you can give any name out here. And I'm saying I just need one replica of it. Meaning I'm also telling Kubernetes that, you know what, how many kind of replicas do I want? Like, how many kind of applications of the same set do I want? How many containers of the same set do I want? If you give 10, you will have 10 different applications managed by Kubernetes in a load balanced way. But for our basically what do you say, a class out here, I am now giving it as what, one replica. And if you look at this, right, replica is falling under a parent called what, specifications. And I'm now saying that it's one replica. Selector, I'm just saying, okay, fine, this is my app. I'm just giving, let's say, an app label out here. And finally, I'm saying inside this spec, I'm again giving another spec, and I'm saying containers. The name of the container is my image. I'm just giving a sample out here, and I'm saying it is nginx, meaning please go to the Docker hub. Basically take an image called nginx image out there, and the ports that you need to expose is a port 80 for this particular container. So whatever I'm doing using a Docker run, right, exposing all the ports, giving the name, and declaring the containers, I am just doing it in the YAML syntax out here. And this is what a deployment, meaning I am doing what, a pod deployment out here. I also have another file called services.yml. And if you look at this particular file out here, let me do a new file out here and say YML, a language called YAML, and paste it out here. Let's say save. I'll say service.yaml. Say save. And if you look at the service right now, right, what it's telling is saying, okay, fine, API version is something v1, kind is a service. Because this is not a pod, this is a service for my pod. What is the type of the service? A load balancer operating over port 80. So I am exposing the port 80 on the infrastructure layer in doing by doing this. and I'm opening up a port called 80 on the container by doing this. So two different YAML files out here. Now how can I use it, or where can I use it? So I'll come back to my Azure portal. I'll say go to the resource groups, create a new resource group, and say Kubernetes, and like ECS2, just create something. And here I'll just type in Kubernetes service. This is a service that I want to basically go ahead and create. I'll say create, and I'll say create a Kubernetes cluster. And now I'll say, okay, fine, this is the resource group that I want to select. Like I have one resource group which is Kubernetes out here. And I'll say the cluster name is my sample cluster, something like this, which is unique. EastUS2. I don't need availability out here. Like I'm okay to do without, okay to go ahead without the availability. And now it's asking me what kind of scaling methodology that you want. Do you want an auto scale? Do you want a manual scale? For now, I'll select a manual scale, and I'll say the number of nodes, meaning the number of virtual machines that you want in this architecture. There will be one virtual machine by default, which is the master, but how many nodes in this particular cluster that you want? I'll say single node cluster, and I can say the size of the virtual machine that basically I want to is I want to basically reduce the size to, let's say, something like B1S or B2S, something like this, which is, let's say, a bit on the cheaper side. Let's just select, and now it says okay, fine, great, you have a size B2S with 2 core CPU with one virtual machine, meaning you'll now be created with one master node which Microsoft is going to manage, and you'll have one virtual machine to host your containers. So I'll say okay, great. Now I'll say node pool, I'll select everything default, and I'm basically using a Linux operating system out here, and I'll say okay, I don't want even the virtual machine scale set. So I'm just taking all the options that are by default available. I'll say networking, I'll let Microsoft decide what my networking is, and I have a load balancer that Microsoft is kind of wants to give me out here. I'll say fine, integrate sorry, integrations. It's also asking me, do you have a container registry where I can go ahead and integrate you with? I'll say not a problem. And now it's telling, how do I monitor my Kubernetes cluster? It's telling I'll create a default workspace called log analytics workspace for you. I'll give that to you. You can go ahead and basically monitor all your cluster, and finally tags, I'll review and create it. So I'm creating what? A single node cluster, and I'm using all the options that are given by Azure by default. So Azure now is going to take care of all these things that are running in the backend. I don't even use some command called kubectl. I don't even install all these things out, because all these things are now taken care by Microsoft. And I'll say okay, fine, create this out. So it's now going ahead and provisioning me a Kubernetes cluster, which is a single node cluster in nature, and it is now going ahead and provisioning this cluster, and it's telling okay, fine, the cluster is ready, what do you want to do with this now? Let's see how it looks like and all that stuff. It takes about 5 minutes for the cluster to get created, and since it's a single node cluster, I wouldn't say it is 5 minutes, it will be about 2 or 3 minutes basically. So what we are creating is we are creating virtual machines that are connected to each other in form of a cluster, and which is managed by a language, or which is managed by a service or a technology called as Kubernetes. And this is a platform as a service kind of a technology, guys. This is a platform as a service completely managed by Microsoft in the backend. I am not configuring the node, I am not configuring the clusters, I'm not doing all these things out. One of the very simple and easiest way in order to learn Kubernetes, so start learning Kubernetes. When you actually go into, let's say, the nodes and all these stuff, right? It's actually, the subject has a lot of depth. Kubernetes is still evolving, it's evolving at a rapid pace, and it has a lot of depth out here. You need to understand a language called kubectl and all that stuff, and see how you can use kubectl and everything. But for now, I'm just using a very simple Kubernetes, a managed cluster. That's what it's calling, is a managed cluster. It's a managed cluster service that Microsoft is provisioning me out. And once it is provisioned, I will basically use my YAML files in order to go ahead and deploy the pods and deploy the load balancing service. So why a load balancer service? In order for your traffic or in order for your application to be exposed to the world, you need some kind of a service, right? Kubernetes here implements a load balancer. So just imagine that you are using, let's say, the Microsoft virtual machine service. You created 3 different virtual machines, you have a load balancer and all that stuff, and you deployed all your applications, and now it's running. But when let's say the virtual machine goes down, all three go down, all the, or let's say two go down, then how you do you monitor it? How do you patch it out? Right? This is the management. To avoid this, we are using something known as Kubernetes, and also we are now deploying our applications inside a container. So this is what a container orchestration platform, meaning this is the service who manages all your containers. Any questions till here, guys? Anything with the YAML or anything till we are creating the service out here? Anything as such, guys? Anything? Are you all able to follow this, or is it tricky, confusing? Anything? Anything, guys?
So we can also do the same Kubernetes cluster in the VMs, right? Without
Mhm.
utilizing the PaaS.
Yes, you can also do the same in the VMs without utilizing the PaaS, for which you need to install the Docker engine, install Kubernetes services inside the VM and all that stuff, and configure master and slave nodes. And then you can manage. You can do everything that we are doing using the Kubernetes cluster on the IaaS side of it.
Okay.
But you'll need to just understand what kubectl is and all that stuff. Like there is a language called kubectl which Kubernetes uses, and Kubernetes also has a great amount of documentation. Kubernetes.io, open source and all that stuff, and it'll tell you what to install and all that stuff and everything. And it tells you this also has a good amount of documentation. And if someone asks Kubernetes or K8s, right, both are the same thing. So it tells you how to set up the Kubernetes, view the concepts and all that stuff. So it offers all a great amount of training also out here. So this is the documentation, and inside which you can basically have concepts saying Kubernetes architecture, workloads, storage and all that stuff. So it's actually a lot deep than what we actually think is. Kubernetes is actually a lot deep, but since we are using a service like Azure Kubernetes service, right, we don't actually manage all these things out. We don't actually do all these things out. Microsoft kind of manages it out. Does this make sense, guys? So this is the documentation, and it'll be great if you can just study or just read this documentation on what exactly is Kubernetes and how to install Kubernetes and all that stuff. Like at a later point, I would say suggest at a later point. First, let's basically see what an Azure Kubernetes what an Azure Kubernetes service is, and how can we use a Kubernetes service out here. And then basically we can go ahead and let's say interact with the Kubernetes cluster that is there as a infrastructure as a service. Is that okay?
Okay.
Okay, so while this is getting installed, I mean, while this is getting initiated, generally it takes about 5 to 6 minutes to get, the service to be running up and running and all that stuff. It depends upon, the day also. So let's give it a minute. But while this is getting installed, right, let's quickly build a custom image. Now, yeah, this is almost done. It's like, giving you the clusters created, and now it's just giving you something like role assignments and all that stuff. Should be almost done in a minute. Yes, it's done. So I'm going inside my cluster right now, and this is how my cluster looks like. It says, okay, fine, you have one node count and all that stuff. And in the left hand side, right, under the Kubernetes resources, I have something known as workloads, which are nothing but container or pods. Now, what I want to give here is that I'll say add with YAML, and I'll give my YAML file. This is the YAML file. This is the app.yaml file. I'll take the entire YAML file. I'll put it in here and I'll say add. What I'm doing is I'm deploying my container right now. Now this is the app deployment, and if you go inside it, right, and go inside something known as events, it'll now say, okay, fine, this is the control set and all that stuff. And if you go still more inside it and see, it'll also give you the YAML definition. It will tell you what all it is doing. If you look at the live logs, it will tell you what all this is doing. It will go ahead, pull the image, create a container out of it and all that stuff, and it'll tell you, okay, fine, select a pod to continue. Let's see this one, and let's see this one. So it'll go ahead and it'll say, okay, fine, what all are the things that I'm doing out here, and it'll give you even live events and logs and all that stuff. Now this will take some time in order to load up. So let's come back to our cluster and let's give it a couple of refresh out here. And now you see the service is started running. The service now started running out here, where it's saying, okay, fine, this is your service which is ready. And if you go here, it'll tell you, okay, fine, I have, like, say, basically went ahead, pulled the image out, and pulling the image, I created a container and I've started the container, telling that, okay, fine, this is what I have done till now. Where it pulled the image from? It pulled the image from something known as hub.docker.com. It went into hub.docker.com and pulled all this image out here with the latest tags and all that stuff. And if you look at right in the backend, it is using the kubectl command. So we did not even basically look at kubectl. It's just going ahead in the backend and using something known as a kubectl command out here in order to pull all these things out. This is pulled. But how do I look at my application right now? Where do I look at my application right now is that your application should be exposed to the internet using something known as service and ingress. And you need a service called as a load balancer. How do I add that service? I'll say add with YAML, and I'm using this particular YAML file, and I'm saying, you know what, the service that I want to expose is my app, because that's something that I deployed, right? The service that I want to use is my app. So I'll basically copy the entire thing and I'll paste it out here and I'll say add. So I am now creating a load balancing service, and once the load balancer is kind of running, it will give me an external IP. It'll give me a public IP with an external address so that I can play around with that. So let's give it a refresh a couple of times. It'll take like about a minute or so in order to provision the services. And now it is provisioned and I have a public IP out here, right? And when I open this public IP, it'll take some time in order to basically, give the container and all that stuff. But once this public IP is provisioned, once this public IP is operational, I should be able to see my Nginx engine running on this particular Kubernetes cluster. Like this is the first boot, right? It'll take some time and it'll basically show that, I have an Nginx engine that is running on this particular port called TCP and all that stuff. Now it's kind of down, and it'll take some time in order to, come back as such. Let me see. This is my service, and sorry, let me basically go to my YAML file. Service YAML file, it's selecting the YAML and it says my service, it says my app, and my app is also running out here. So this is app deployment, and let me see the YAML definition of this. Okay, let me see if I missed out on anything. Let's see. So this app deployment, and it says my app, which is great, which is good, not a problem. And I pulled my app, which is great. Let me again come back to my service and let's see if it is running or not. Yeah. So this is now running out here. And you can do a custom domain binding and do an SSL out to this also. So this is an IP, an A record. You can give a custom domain binding by using, let's say, the domain provider and all that stuff. And now it's telling, you know what, okay, fine, welcome to the Nginx engine. Meaning I use two different files out here, one called app, the other called services.yaml. and I just made sure to run a container by pulling this particular image, and now this particular server is running out of a Kubernetes cluster exposed on a load balancer. Now the best part of it is that you can have multiple applications, not one, not two, multiple applications in the form of pods, meaning containers, and you can load balance them. You can do all that stuff upon your Kubernetes cluster. Guys, are you all following this out? Is this okay?
These files are look strange. So some are showing that cluster IPs but nothing is there for pod, right?
For I mean, I didn't
Pod.
get your question. I'm sorry.
I mean,
See,
so these
pod is a container, right? Pod is a container. And yesterday when we deployed your container on top of a virtual machine, right? What did we do? We took the IP of the virtual machine and then we were looking into it, right? Meaning you have a virtual machine acting as a service to expose your container. And here you have a load balancer acting as a service to expose your container. And all these services are back in Kubernetes, which is basically monitoring your services and all that stuff. So what was your question, Chandra? Like about which one that is strange?
So I want to add one more pod.
If you want to add one more pod, let's go into the workload, add one more pod, select a YAML file, write your YAML file out here. Let's say it is III start, or let's say something it's HTTPD container. Let's do that. Let's say this is deployment, this is app deployment. Let's say this is app deployment -1 and this is deployments, and let's say this is my image -1, and let's use a server like HTTPD, which is, let's say, the uh, the Tomcat server, I believe. I think some of the web server that is running out there. So I'll say this is HTTPD one replica, container port is 80. I need this out, and I'll come to the load balance service. I'll say this is my service one. This is kind of a service, and type is load balancer, and this is my app one. I am selecting the application that I'm basically giving out here, and I'm saying save. I'm taking this YAML file out here, pasting it out here in my Kubernetes pod, and now I am creating a pod deployment out here, which is called app deployment one. This is app deployment one. This is a second application. Image is HTTPD. That is something that I've taken from the internet. That's something that I'm basically pulling from the hub.docker.com. And if I go into this out, and if I look into the events out here, this is the second pod right now that I've kind of deployed out. And if I basically look into what exactly happened out there, it says, you know what, I pulled all these images, I've started your container. I mean, your container is running in the form of a pod. How do you expose this particular service right now? Is you need another load balancer, right? You need another service to expose this, because this
Cannot we
IP
use existing? Okay.
you cannot use the existing because you have allocated this particular IP. Because how do you basically use the existing? Because you already expose this particular IP to a service out here, which is telling that okay, fine, it is at a port 80, and again I'm using this another pod at a port 80 again. I've exposed the port 80, right? So if you want to use the same service out there, you'll need to expose another port out there, like 8080 or something like that, and point it out to the service. But this will cause a lot of confusion, because if you are giving this IP to a user, if you just want to type this IP, you want to get a website, right? Now I want to do another deployment out here. So I'll say deploy with YAML. I'll take this file, the new YAML file that I created, which is a new load balancing service. I'm exposing the port 80 again on that particular load balancing service, and I'm saying add. Now I'm creating another service out here, which is a load balancer again, with a different IP to expose my second container. So the number of containers you have, the number of IPs you will have, because you want to make deployments of websites, right? And for each and every website, I want to dedicate one particular pod, and this is a single pod out here, right? If I have multi-node cluster, let's say if I have 4 or 5 node cluster, all these containers will be playing around on top of those clusters, depending upon which node is healthy. And if I say node, it's nothing but a virtual machine that is running in the backend. Which node is healthy, how is it, and all that stuff. And all the orchestration is done by Kubernetes. Does this make sense, Chandra?
Yes. So
Mhm.
if now we are using one node cluster, so if we suppose
Right.
we are using two node cluster means
Mhm.
we will see two pods in the workloads.
No. See, pod is different. Pod is container. Node is your virtual machine that is running in the backend. This is a PaaS service. You will not be able to see the nodes that are running. You'll only be able to control the pods that you're running on top of the nodes. This is a single node cluster, right? If I do a multi-node cluster, what is going to happen is that Microsoft in the backend will give you multiple nodes, meaning multiple virtual machines on top of which your containers can be orchestrated. And container is the pod. So the terminology here is container is equal to pod and node is equal to the virtual machine that is running in the backend. So you're not able to see the nodes because this is what a platform as a service. And if you come down here, it'll tell you what are the node pools and the cluster configuration and all that stuff. Tell you what kind of a cluster you have and all that stuff out here. So what I am talking about is just the services that I'm using. For me as an end user, the best thing what Azure Kubernetes service kind of provides me out here is a platform as a service offering where I can forget about what the nodes are, what all these things are, how the load balancing is, sorry, how the load balancing is happening and all that stuff, and only worry about my pods. Because my pod out here, which these two things out here, these are my main applications out here. I can only worry
We,
about this.
we can call this as a container, or we can call it as a pod.
In the
Because
Kubernetes, this is called as a pod. Pod is equal to container. But in Kubernetes, you don't call this as a container. There's a terminology for it. It's called as what a like a pod is nothing but a container out here. And a node, right? This pod, the container is running on top of what a virtual machine in the backend because you need an infrastructure to run, right?
right.
This virtual machine is the node, which is
Okay.
in the backend.
Mm.
And you're exposing this virtual machine using a public IP or using a service called as a load balancer. And you're exposing the machine out here.
Okay.
This is the architecture
Okay.
of Kubernetes. Okay, so does
Yeah,
this
got
make
it. So
yeah. Mhm.
yeah, got it. So we cannot see the virtual machines, but we can create the
Exactly.
service load balance service here.
Exactly. It's same like a web app, right? So in a web app, you will not be able to see a virtual machine that is running in the backend, but you know that it's running on a virtual machine. In a Kubernetes cluster, meaning in an Azure Kubernetes service, you will not be able to see the backend running VMs. You won't be able to manage the backend running VMs, but you'll only be able to see the applications that you have deployed. And you can deploy multiple applications out here.
Yeah, got it. Thanks.
Okay. Guys, does this make sense? Any more questions here? Anything with this one? Anything with the service? Now, the assignment for you all today is that I used a pod or I used basically a container. I used the image that basically that I've acquired to run the container from hub.docker.com, right? I went ahead, took an Nginx image. I want you all to create your own image. So I want this to happen. This is my requirement right now. Is that I want you all to create an image of a .NET application like we did yesterday. So build the image, push this image into an Azure container registry, into something known as an Azure container registry out here, using the docker push command, and connect your container registry with Kubernetes. Connect your container registry with Azure Kubernetes service. How do you do that? Is very simple. When I created Kubernetes cluster, right, it asked me that if I want to go ahead and basically connect it to, let's say, an Azure container registry. If I do a Kubernetes cluster here, in this particular page or in this particular option in integrations, it's asking me whether you want to go ahead and connect it to a Kubernetes cluster. Go ahead, create a cluster, push your images, and then add it out here. Now, when you do a app.yaml file, I want your application not to refer to a public image, but I want your application to refer to the image that is there in your Azure Kubernetes or Azure Container Service. How do you do that? Under this, you have a folder called ACR, right? Here, I also have a given you a sample file out here. So you just basically give the name of your registry. So this is nothing but the name of your app registry, and then refer to the image. This is the only thing that will change in your entire deployment. This is the only thing that will change. Nothing else is changing. And if you look at your services.yaml, it is the same. Just a load balancer service, but this time you're referring to my app, and my app out here is referring to an image from your Azure from your Azure container registry out here. So again, create a virtual machine, build an image using a Docker file, and after building an image, push the image into Azure container repository or container registry. From that, link it to the Azure Kubernetes cluster. And guys, please be very careful if you're creating a Kubernetes cluster or Kubernetes service in, let's say, a paid account, right? Please make sure to use the minimal thing out here, because it will create a lot of services in the backend. Kubernetes is very huge, and the cost is also very high for Kubernetes cluster. So please make sure to use a single node cluster with a minimal size of a virtual machine, and then try out your practice out here. Okay, I've also given the YAML files out here. Please try it firstly with the Docker Hub image. Secondly, push your images to the container repository out here, container registry out there, and then pull your image from the container registry. Please let me know what are the challenges that you're facing with this. This is the manual way. What we are going to look at is that how can you use Azure DevOps pipelines to do all these things, to, let's say, build your images, to push that image into, let's say, something like a registry. Using that registry, how do you basically use Kubernetes from there? All these things is something that we are going to do using a CI/CD pipelines. Okay, this is the agenda what I have. So at the end of the day, everything boils down. Now, all these things, you won't even create all these things from the portal. You can use ARM or Terraform in order to create container repository, container registries, and Kubernetes clusters out there. And then basically deploy your pods and everything using Azure DevOps pipelines. So all these YAML files, right, we'll again use these ones. We'll again use these YAML files basically. We'll see how it works out and all that stuff. Okay. Any questions till now, guys? Anything? Like, do you all follow the agenda what we're trying to do out here? Is that let's not do manually. Let's not create all these images manually. Let's create it using the Azure DevOps pipeline and see how you can create the images and how you can push the images out there. Okay. Guys, are you able to follow this out? Any issues with this? One suggestion with Docker and Kubernetes is that please watch as many as times, please watch this videos as many as times you want, because these are services that are a bit sophisticated than what we were kind of dealing with till now. These are services which require a bit of understanding about networking and all that stuff, so all the concepts kind of play around. So that's the reason I have placed this in the very last of our course, and by this Saturday we should be able to finish all these things, guys. Tomorrow we are going to look at how to basically build your own images and deploy it, and then how to use a pipeline to build your own images and deploy it on top of a Kubernetes cluster. That will kind of mark an end to the entire course that we have. Guys, any questions on this, anything as such?
Yeah, yesterday we showed that some of the for Docker Windows app
Mm-hmm.
to build the containers.
Right.
So will that
To
cover?
install the Docker, isn't it? Yeah, I'll cover that out. Like, I mean, you're talking about this one, right?
Yeah, app one, Azure, the
The
Docker
Docker
app.
app. Yeah, I've just installed this Docker app on my machine, but I can show you how to install it out. That is not a big issue. I can show that also, not a problem.
So from there we can create the containers, right, and push
Yeah, you
to
can
the
create the containers.
Docker.
Yes, yes. Since I'm using this service a lot, right? I've installed it on my machine. But if this is something that you're doing just for a demo, you can just install a Linux virtual machine and do on top of it. All the orchestration and all you can do on top of it. Not an issue. Is that okay, Chandra? But I'll show
Yes.
you how to kind of install it. Like, I'll create a virtual machine with Windows 10 Home, and I'll show you how to install that out.
Okay. Great. Thanks.
Okay, any more questions, guys? Okay, if there are no more further questions, guys, then I'm good to close the session for the day. Have a great day ahead, and we'll meet tomorrow. Thank you.
Thank you.
Thank you.